A lullaby of gravity. This act sets the foundation, how the moon's gravity works, how Earth responds, and why tides even exist. Your viewers will drift into an ancient, invisible force that shapes life every day. The first pull. You begin with the simplest yet most powerful idea, gravity. Explain that every object with mass exerts gravity, but the moon's pull is unique because it's so close. Describe how the moon pulls the ocean's surface toward it, not in one big wave, but in a giant bulge that slowly follows its orbit. Use a simple analogy. Imagine Earth wears a soft blanket of water that's gently tugged toward the moon. The Earth-Moon dance. Zoom out, show how Earth and Moon orbit a common center of mass, the barycenter, which is actually inside Earth but not at its exact center. Reveal how this subtle off-center motion affects the ocean's shape. Explain that this shared orbit causes the ocean to bulge on both the near side, toward the moon, and the far side, due to centrifugal force. The birth of the moon. Go back in time, about 4.5 billion years ago, a Mars-sized body likely collided with young Earth. Bits of Earth's crust and mantle splashed into orbit, forming a disk of molten rock. Over time, this material gathered into the moon, a story told by moon rocks, craters, and isotopic fingerprints. Point out how, ever since, the moon has been Earth's closest partner, creating the conditions for tides. Early tides in ancient seas. Invite viewers to imagine the Hadean Earth, closer moon, faster rotation, huge tidal ranges. Explain that billions of years ago, tides were dozens of times higher because the moon was closer. These dramatic tides might have mixed chemical soups in tidal pools, a place where some scientists think life's first building blocks formed. The twin tidal bulges. Clarify why we don't just get a single high tide per day. The water bulges toward the moon, but also away on the opposite side. On the near side, the moon's gravity pulls water toward it. On the far side, centrifugal force from Earth's spin and orbit creates a second bulge. This is why most coasts experience too high and too low tides each day. The role of centrifugal force. Dig into this slightly trickier idea. Centrifugal force is a pseudo-force, felt because Earth and Moon spin around a shared point. Explain how this force pushes water outward on the far side, creating the opposite tidal bulge. You can use a spinning merry-go-round analogy to help viewers see this hidden force. The shape of the oceans. Tides don't happen in a perfect circle. Earth's continents, ocean basins, and seabeds shape the way tides move. Show examples. The huge Bay of Fundy tides versus the almost tideless Mediterranean. Explain that the ocean sloshes like water in an oddly shaped bathtub, creating local differences. The tidal cycle. Guide viewers to a normal day on the coast. 2 high tides, 2 low tides, roughly every 12 hours and 25 minutes apart. Explain why tides shift forward by about 50 minutes each day. Because the moon moves in its orbit, too. This sets the rhythm for fishermen, sailors, and coastal life everywhere. Tidal lag. Tidal bulges don't line up perfectly under the moon. They're dragged ahead slightly by Earth's rotation. This lag is what lets the moon's gravity tug on the bulge and slow Earth's spin. Over millions of years, this tiny friction has lengthened Earth's day from about 6 hours to 24. The Earth's tidal break. End Act 1 with a fascinating fact. The same tidal friction that gives us the daily ebb and flow also acts as a break on Earth's spin. The moon is slowly drifting away, about 3.8 centimeters per year, because of this energy transfer. This means days get longer over geologic time, and the Earth-Moon dance will continue to evolve. The sun joins the dance. After showing how the moon's gravity shapes the tides, Act 2 adds a new player, the sun. Most people don't realize the sun's gravity pulls Earth's oceans too, but its role is subtle, powerful, and crucial to the beautiful rhythm we see along every coastline. A second gravitational force. Begin by inviting viewers to picture the solar system, The Sun is about 27 million times more massive than the Moon, yet the Moon's tides are stronger. Why? Because tidal force depends not just on mass, but also on distance. The Moon is so close that its gravitational pull on the ocean varies more across Earth's diameter than the Sun's does. The Sun's pull adds a second, steady beat to the tidal dance. The solar tide. Describe how the Sun creates its own tidal bulges, just like the Moon, but about half as strong. This means that at any given time, the ocean is influenced by two sets of tidal forces, the lunar tide and the solar tide, overlapping and combining. Use a soft analogy. It's like two musicians playing in harmony. Sometimes their notes build each other up, sometimes they cancel out. Spring tides. Here you reveal the first major combined effect, spring tides. No, it's not about the season. Spring comes from the old word springen, meaning to rise up. When the Sun, Moon, and Earth line up during a full moon or new moon, their gravitational pulls combine. The result, extra high tides and extra low tides. Bring in real examples, dramatic spring tides that fishermen plan for and beachgoers watch in awe. Neap tides. Next, the opposite, neap tides. Explain that during the first and third quarters of the moon, the Sun and Moon are at right angles relative to Earth. Their gravitational pulls partially cancel each other out. This creates the lowest tidal range. High tides aren't as high, and low tides aren't as low. Share how sailors, clam diggers, and even coastal animals adapt to these gentler tides. The ecliptic connection. Take your audience deeper into astronomy. The Sun, Earth, and Moon all move along an imaginary plane called the ecliptic. The alignment of orbits affects how perfectly the Sun and Moon's tidal forces reinforce or oppose each other. Sometimes the alignment is perfect, creating especially dramatic king tides that can flood coastal streets. Syzygy, the perfect lineup. Introduce the beautiful term syzygy, when Earth, Moon, and Sun align in a straight line. Syzygy is the cosmic moment that triggers the strongest spring tides. It also causes solar and lunar eclipses. Explain how ancient astronomers and astrologers revered syzygies, believing they held special power. Equinox tides. Reveal that tides can peak seasonally too. During the equinoxes, when day and night are equal, the Sun crosses the celestial equator. These alignments can amplify spring tides even more. In many coastal cultures, spring and fall equinox tides have been times of harvest, celebration, and caution for flooding. Perigee and perihelion. Combine lunar and solar distance factors. When the Moon is closest to Earth, perigee, and Earth is closest to the Sun, perihelion, which happens in early January, tides can reach their most extreme. These perigean spring tides, or king tides, can cause surprise flooding in coastal cities. How coastal communities prepare. Explain how communities rely on tide tables and lunar calendars to plan for spring and neap tides. Fishermen know when to lay nets for maximum catch. Engineers plan port dredging and harbor schedules. Even wildlife, seabirds, crabs, and fish, time their breeding and feeding to these cosmic cycles. A cosmic tug-of-war. Close Act 2 with a poetic image. Every ocean on Earth is part of a never-ending tug-of-war between the Sun and the Moon. The Sun's massive pull stabilizes Earth's orbit, warms the seas, and shapes tides alongside the Moon's closer, gentler tug. Together, they weave the endless rise and fall, a rhythm we live by, whether we notice or not. Shaping the shores. The ocean's endless chisel. Begin with the big picture. Tides act like a slow-motion sculptor, chipping away at rocks, cliffs, and sand over thousands to millions of years. Explain that the rise and fall of water creates constant erosion. Rocks break, pebbles tumble, sand shifts. Paint the image. Each wave, each pull and push, is like a tiny chisel stroke, reshaping the coast. Cliffs in retreat. Focus on dramatic sea cliffs, like those along England's chalk coasts or California's rugged Big Sur. Show how the pounding of tidal waves at the cliff's base creates sea caves, arches, and eventually sea stacks. Explain why some cliffs retreat by meters every year. Entire fields and villages have fallen into the sea because the tides never stop. Beaches in motion. Zoom in on sandy beaches. To the eye they seem permanent, but in reality, they're moving rivers of sand. With each tide, sand is pulled offshore, pushed back in, or carried sideways by longshore drift. That's why some beaches disappear after storms and reappear weeks later. Coastal engineers build groins and breakwaters to manage this, but the ocean always finds a way around. Tidal flats, muddy wonderlands. Introduce tidal flats, vast expanses of mud or sand exposed at low tide. These flats are some of the most productive ecosystems on Earth, filtering water, trapping nutrients, feeding millions of migratory birds. Explain how the push and pull of tides keep these flats healthy, mixing oxygen into the mud. Hidden lagoons and estuaries. Show how tides carve out estuaries, where rivers meet the sea. Salt and fresh water swirl together, creating brackish environments teeming with life. Tidal flows carry nutrients in and out, creating nursery grounds for fish, crabs, and oysters. Estuaries protect inland areas from flooding by acting like natural shock absorbers. Barrier islands, nature movable shields. Describe how barrier islands form along some coasts. These are long, narrow sand islands parallel to the mainland, created by the action of tides, waves, and currents. They shift position over centuries, sometimes migrating landward as sea levels rise. Barrier islands protect the mainland from storms, but they're fragile, always changing with the tide. The power of storm tides. Reveal how extreme tides during storms shape coasts dramatically overnight. A king tide plus a storm surge can breach dunes, flood streets, or carve new channels through islands. Use real examples like the powerful tidal surge that reshaped parts of the Netherlands and led to the creation of the Delta Works. The Bay of Fundy, Earth's tidal powerhouse. Take viewers to the Bay of Fundy in Canada, home to the highest tides on Earth. Explain why this bay's funnel shape amplifies the incoming tide to heights of 50 feet, 15 meters. Massive tidal bores race upriver, sculpting riverbanks and creating whirlpools that stir up nutrients. It's a living example of how geography shapes tides, and how tides shape geography. Human struggles and adaptations. Show how humans adapt to living with tides. Some cities build sea walls, groins, and beach nourishment programs to protect coasts from erosion. Others, like the Netherlands, use ingenious tidal defenses, adjustable barriers that open and close with tidal cycles. Include stories of communities that have relocated inland as the tides reclaim their shores. The future of changing shores. Close this act by looking forward. As sea levels rise, tidal effects on coasts intensify. Some beaches will vanish. Some wetlands will expand. Scientists use tidal models and satellite data to predict which coasts are most vulnerable. End with a calming thought. The shores may shift, but the moon's pull will keep this ancient rhythm alive for millions of years more. Life between the tides. The intertidal zone is where the sea kisses the land, sometimes dry, sometimes submerged. A habitat that is harsh but teeming with astonishing adaptations. Your audience will learn how life clings, feeds, hides, and blooms in this ever-shifting edge of the ocean. The intertidal realm. Introduce the intertidal zone, the stretch of coastline that's exposed at low tide and covered at high tide. Explain how this zone can vary from gentle sandy beaches to rugged rocky shores to vast mudflats. Each habitat hosts different communities. Some hardy enough to face crashing waves, drying winds, and predators from land and sea. Zonation, layers of life. Guide your viewer through the distinct layers of life. The spray zone, only splashed by waves, home to lichens and tough barnacles. The high intertidal zone, Underwater only during highest tides, home to limpets, periwinkles, and small crabs. The mid-intertidal zone, regularly submerged and exposed, a battleground for mussels, anemones, and sea stars. The low intertidal zone, mostly underwater, lush with seaweed and teeming with fish and larger predators. Masters of attachment. Focus on how creatures hold on in rough surf. Barnacles cement themselves with one of the strongest natural adhesives known. Mussels anchor in colonies using byssal threads, tiny protein ropes that flex with waves. Explain how these adaptations let them survive where any slip would mean certain death. Tide pools, miniature worlds. Bring your audience into tide pools, rocky pockets that trap seawater when the tide recedes. Describe them as tiny aquariums, colorful sea stars hunting mussels, hermit crabs scavenging scraps, anemones waiting to sting tiny fish. Each tide pool changes every day. Salinity, oxygen, and temperature fluctuate wildly, yet life thrives in these miniature seas. Feeding with the tides. Show how many animals feed only when the tide is right. Shorebirds probe mudflats at low tide for worms and clams. Fish come into estuaries on high tides to hunt. Filter feeders like oysters and clams siphon plankton from fresh tidal water. The whole ecosystem is like a buffet that opens twice a day. Predators of the edge. Introduce the hunters, raccoons, foxes, bears, even humans, who raid tidal flats and pools for easy meals. Explain how seagulls drop shellfish from heights to crack them open. In some places, people still gather clams, mussels, and seaweed by hand, timing their foraging with the lunar calendar. Life in the mangroves. Expand the intertidal story beyond rocks and sand. In the tropics, mangrove forests thrive in brackish, tidal zones. Their roots anchor in salty mud, sheltering countless juvenile fish, crustaceans, and birds. Mangroves are nature's coastal defense, absorbing tidal energy and reducing erosion. Coral reefs and tides. Show how some coral reefs, especially nearshore fringing reefs, are also shaped by tidal flows. Corals depend on just the right balance of submersion and exposure to sunlight. Too little water at low tide can stress coral polyps, while steady flows bring fresh nutrients to sustain vibrant reef life. Extreme survivors. Explain that some creatures are true masters of stress. Certain algae survive hours of baking sun when exposed. Mollusks close tight to keep moisture inside. Some species even shut down their metabolism temporarily to wait for the water's return. The intertidal legacy. Close the act by reflecting on how vital these zones are. They produce food, filter water, shelter coastal communities, and protect shorelines. Yet they are fragile, threatened by pollution, overharvesting, and sea level rise. Leave viewers with an image. Every time the tide recedes, it reveals a glimpse into the edge of two worlds, land and sea, coexisting in a timeless embrace. Tidal rivers and bores. This act explores how, in some rare places, tides don't just move ocean water in and out. They surge up rivers, reversing the current, creating massive waves that people can even surf for miles. Your audience will hear amazing real-life stories, natural wonders, and the science behind these strange watery invasions. The river's unexpected reversal. Start with a clear explanation. When a large tide pushes into a river mouth, the rising seawater can overpower the river's usual downstream flow. Instead of always flowing to the ocean, the river reverses temporarily, a backward surge that transforms the river's direction twice daily. What is a tidal bore? Introduce the tidal bore, a tidal wave that rolls up a river channel as the incoming tide squeezes through a narrowing river mouth. Explain how it works. The shape of the river, the speed of the tide, and the shallow riverbed all align to create a sudden, surfable wave. The Severn Bore, England's backwards wave. Bring in the Severn Bore in the UK, one of the most famous bores in the world. Describe how, during big spring tides, a wave up to 2 meters high sweeps upriver for over 20 miles, attracting surfers who ride it for incredible distances. People gather on bridges and riverbanks, waiting for the roar of this ancient phenomenon. The Amazon's Pororoca. Travel to Brazil's Amazon River, where the Pororoca tidal bore is a legend. When the Atlantic's tide surges into the river mouth, it creates waves up to 4 meters high that barrel through the jungle for miles. Local surfers brave debris, crocodiles, and unpredictable currents to ride this wild, muddy wave. The Qiantang Dragon Tide. Move to China's Qiantang River, home of the world's largest tidal bore, nicknamed the Silver Dragon. During the Mid-Autumn Festival, thousands gather to watch a 30-foot wall of water hurtle up the river, foaming and roaring like a freight train. Explain how this bore has shaped local legends and inspired poetry for centuries. Smaller bores around the world. Highlight other places with smaller but fascinating tidal bores. The Ganges and Hooghly rivers in India. The Petit Kodiak River in Canada. The Colorado River Delta before dams tamed its tides. Each one shows how unique local conditions can create these rare events. Ecological impact. Describe how tidal bores stir up sediment, bringing nutrients to riverbanks and floodplains. Certain fish and shrimp species time their migrations to ride the bore upstream. These events help fertilize fertile floodplains, which can be crucial for local agriculture. Dangers of the bore. Show the other side, the destructive potential. In some places, the sudden surge can swamp boats, erode riverbanks, and damage riverside villages. Explain how some communities have built embankments or warning systems to stay safe when the bore arrives. Surfing the bore. Add a fun, human element, the daring surfers and kayakers who chase tidal bores around the world. Explain how riding a bore is different from ocean surfing. It's a single, unbroken wave that can carry you for kilometers. Many surfers plan for months, waiting for the right alignment of tide, river shape, and weather. The timeless pulse. Wrap up with a reflection. Tidal bores remind us that the moon's pull doesn't just touch coastlines, it pulses deep inland, connecting oceans, rivers, people, and even forests in one timeless cycle. End with the calming image, rivers that breathe backwards twice a day, whispering the moon's song far from the sea. Tidal energy, harnessing the moon's power. This act opens your viewer's eyes to the idea that tides are more than just a beautiful natural rhythm. They are also a reliable, predictable, and potentially huge source of clean energy. We'll explore how it works, where it's happening, and what the future could look like. The power locked in the tides. Begin with the basics. The rising and falling of billions of tons of water creates enormous kinetic and potential energy. Unlike solar or wind power, tides are perfectly predictable. We know the moon's orbit centuries in advance. This makes tidal power one of the most reliable renewable energy sources on Earth. How tidal energy works. Explain the main idea. Tidal energy can be harvested in two main ways. Tidal range, capturing the difference in water height between high and low tide. Tidal stream, capturing the horizontal flow of tidal currents like an underwater wind turbine. Use simple visuals, sluice gates, turbines, underwater propellers spinning gently. Tidal barrages. Zoom in on tidal barrages, huge dams built across estuaries or bays. When the tide comes in, gates close, trapping water. At low tide, the gates open, and water rushes through turbines to generate electricity. The most famous is the La Rance barrage in France, which has generated power since 1966. Underwater turbines. Show the newer technology, underwater turbines or tidal stream generators. These machines look like underwater windmills, fixed to the seafloor in places with strong tidal currents. They spin silently as the tide flows in and out, no dam needed, less impact on marine life. Global hotspots. Take viewers around the world to see where tidal energy is already a reality. La Rance, France, still a model for future tidal barrages. Magen Project, Scotland, the world's largest planned tidal stream farm, using dozens of seabed turbines. Siwa Lake, South Korea, the world's biggest tidal power station by installed capacity. Environmental impacts. Be honest about challenges. Building a barrage can change local ecosystems by trapping sediment, altering fish migration, or affecting tidal flats. Underwater turbines may pose risks to marine mammals and fish, but modern designs aim to spin slowly and avoid harming creatures. Engineers and ecologists work together to balance clean energy with healthy coasts. The promise of predictability. Highlight the unique advantage. Tidal energy is as reliable as the moon. Unlike solar and wind, which depend on weather, we can predict tides with pinpoint accuracy for centuries. This means tidal energy could help balance an electric grid, filling gaps when wind and solar power dip. Tidal lagoons, a new concept. Introduce a newer idea, tidal lagoons. Instead of damming an entire estuary, engineers build an enclosed lagoon on the coast. As tides rise and fall, water flows in and out through turbines. This can reduce environmental disruption while still generating significant power. Challenges to overcome. Explain why tidal power isn't everywhere yet. High upfront costs, complex engineering in harsh marine conditions, and long permitting processes. Yet, as technology improves, costs come down. Some communities now see tidal energy as a piece of the renewable puzzle. The moon's gift for the future. Close this act with a hopeful vision. The moon's gravitational embrace, unchanged for billions of years, could power lights in our homes, schools, and cities far into the future. A reminder that we are literally riding the cosmic dance of tides, turning an ancient force into clean energy for generations to come. Tides in myth, culture, and folklore. Across cultures and centuries, the mysterious rise and fall of the sea has inspired fear, awe, and countless legends. In this act, your audience drifts through ancient stories, sacred beliefs, and strange customs, proof that tides have shaped not only our coasts, but our imagination. When the sea breathed. Begin with the universal wonder. For ancient people, the ocean seemed alive, breathing in, breathing out. Tides were among the first natural phenomena that humans noticed but could not control. This mystery inspired myths of sea gods, lunar goddesses, and creatures that swallowed and released the sea each day. Moon goddesses and tidal power. Introduced the moon's timeless place in myth. Selene for the Greeks, Luna for the Romans, Chandra for Hindus, Tsukuyomi in Japan. In many cultures, the moon was a goddess with power over the water, the crops, even fertility, because people saw her linked to the ocean's pulse. The Norse sea giants. Take your viewers north. Norse myths imagined huge sea giants, Jormungandr, the world serpent, coiled around the earth, its movement causing waves and tides. Viking sailors told tales of this monster thrashing its tail, stirring the ocean and shaping dangerous currents. The Maori's tidal lore. Shift to Polynesia. The Maori of New Zealand have legends of the sea god Tangaroa, ruler of all tides and marine life. Fishermen would chant prayers to Tangaroa before venturing out, asking the god to calm the waves or send generous fish during favorable, the Inuit and tidal cycles. Move to the Arctic. Inuit stories link tides to the moon goddess Malina and her brother, the sun god Iningin. Some stories say their endless chase across the sky pulls the ocean in and out, a cosmic race that keeps life in balance. Ancient harvest festivals. Describe how coastal communities worldwide have celebrated tides as times of bounty. In parts of Southeast Asia, massive clam digs coincide with extreme low tides during the new moon. In the UK, the ancient Lammas Day once aligned with low tides for gathering seaweed to fertilize fields. Tides and eclipses, omens and wonders. Explain how ancient people connected dramatic tides with eclipses, syzygies when the sun, moon, and earth align. They noticed tides were strongest at these times and often wove this into omens, prophecies, or royal rituals to ensure good harvests or safe sailing. Stories of drowned lands bring in haunting legends. In many cultures, there are myths of sunken cities swallowed by the tides, like Cantaragwaelid, the Welsh Atlantis, lost to a great tide when a drunken gatekeeper failed to close the sea gates. Such stories warn people of the sea's unstoppable force. Folklore still alive. Show how folklore persists today. Fishermen in remote communities still plan by the lunar calendar. Many Pacific Islanders tell moon and tide stories to children so they learn how to read the sea. Local festivals celebrate the highest tides of the year with boat parades and dances. Tides, belief, and the future. End the act by reflecting. Even as science explains tides with physics and orbital mechanics, the magic hasn't faded. Today, artists, poets, and coastal communities still find spiritual meaning in the moon's pull. It reminds us that no matter how advanced we become, we are still tethered to the same ancient, timeless rhythm. Tides and the changing climate. So far, your viewers have learned how tides work, how they shape shores, how they give us energy, and how they've inspired cultures. But in our own lifetime, the greatest tidal transformation may be unfolding, how a warming planet is shifting the timeless patterns we once took for granted. Sea levels on the rise. Begin with the big truth. As global temperatures climb, glaciers melt and seawater expands. This pushes average sea levels higher. But tides don't just rise equally everywhere. Explain how local factors like ocean currents, wind patterns, and coastal shape mean some places see extreme tidal flooding while others barely change. The tide meets the storm. Combine tides and storms. When high tides align with powerful storms, they create storm surges. These surges push ocean water far inland, flooding streets and homes. Highlight examples: hurricanes in the Gulf Coast, typhoons in the Pacific, how coastal cities now watch tide tables and weather forecasts like never before. King tides, nature's warning. Introduce king tides, naturally occurring, exceptionally high tides during new or full moons, when the moon is closest to Earth, perigee. Explain how scientists use king tides as a crystal ball, showing how everyday tides could look in 50 years as sea levels rise. Many communities hold king tide walks to help people see future flood lines. Ghost forests, tidal invasion. Show a haunting side effect. In low-lying coastal areas, rising saltwater kills forests from the roots up. This creates eerie, ghost forests, of dead trees, standing like skeletons in brackish marshes. It's a visual sign that the line between sea and land is shifting, with tides claiming new ground. Saltwater intrusion. Zoom in on groundwater. As tides creep higher, saltwater seeps into freshwater aquifers. This threatens drinking water for millions, from small islands to large river deltas. Farmers face salty soil that ruins crops, a hidden crisis unfolding wherever the ocean's reach grows longer. Wetlands on the move. Describe how some ecosystems try to adapt. Marshes and tidal wetlands can migrate inland if they have room. These natural buffers absorb tidal energy and protect against floods. But when cities block their way with roads and buildings, wetlands drown instead, a big loss for coastal defense. Cities on the front lines. Take your viewers to cities like Miami, Jakarta, and Bangkok, where sunny day flooding now happens during normal high tides. Local businesses put up barriers, raise buildings, or even install tidal valves to keep seawater from backing up through storm drains. These adaptations show how tide science is now urban planning. Indigenous wisdom and tides. Add a hopeful note: many indigenous coastal communities have centuries of knowledge about living with changing tides. They read signs in the moon, the wind, and animal behavior. Some communities blend this ancient wisdom with modern models to plan for flooding, fishing, and coastal stewardship. Predicting future tides. Highlight the fascinating work of tidal modelers, using satellites, AI, and long-term tide gauge records to predict how tides will shift as ice sheets melt. Explain that these models help cities plan where to build seawalls, when to relocate, and how to protect vulnerable communities. Riding the rising tide. End on a thoughtful note. The moon's gravitational pull hasn't changed, but our actions are raising the baseline. While we can't stop the tide, we can respect it, adapt to it, and work to slow climate change so the rhythm of the tide stays in balance with life on shore. Tides and marine migrations. In this act, your audience will discover how the moon's gentle pull is like a secret signal in the ocean, telling animals when to feed, when to move, when to gather, and when to risk the shore. It's an ancient calendar, older than human civilization, hidden in the rise and fall of every tide. The tidal clockwork. Start with the big idea. Many ocean creatures have biological clocks linked not just to the sun, but to the moon and tides. For some, the daily cycle of high and low tide sets the rhythm of when they hunt, mate, or hide. Scientists call these tidally entrained behaviors. Life perfectly synced to gravity's pull. Crabs on the march. Bring your viewer to a moonlit beach. Millions of tiny crabs emerge from the sand, timing their migrations with the falling tide. On the Pacific coast, ghost crabs scuttle sideways, digging new burrows just above the high tide line. Some species, like the famous red crabs of Christmas Island, use the lunar cycle to begin mass migrations to the sea for spawning. Horseshoe crabs and ancient rituals. Zoom in on one of nature's oldest migrations, Atlantic horseshoe crabs. Every spring, during the highest spring tides near the full and new moons, thousands crawl ashore to lay eggs. Their tiny green eggs fuel entire food webs, feeding migrating shorebirds who travel thousands of miles to feast at just the right moment. Eels and the moon's secret paths. Take your audience under the waves to follow mysterious eels. European and American eels spend most of their lives in rivers and lakes but migrate thousands of miles to spawn in the Sargasso Sea. Some scientists believe they use the moon and tidal currents to navigate this hidden route, though much about their journey remains a mystery. Tidal cues for fish spawning. Reveal how some fish use the tides as a delivery system for their young. Grunion, a silvery fish in California, come ashore during the highest spring tides to lay eggs in the sand. 2 weeks later, the next big tide washes the hatchlings back to sea, a perfect lunar clock. Whales and tidal feeding grounds. Move up the food chain to whales. Certain bays and tidal straits concentrate nutrients as tides flow through narrow passages. Humpback and gray whales gather in these areas to feed on dense schools of krill and fish churned up by the changing tide, like a buffet that resets every 6 hours. Sea turtles and lunar landings. Describe how some sea turtles time their nesting with tides. During full or new moons, higher tides make it easier for females to crawl beyond the beach's reach, lay eggs safely above the high tide line, and return to sea. Hatchlings later race down the sand at night, helped by the outgoing tide to escape predators. Migratory birds and tidal flats. Shift to the sky. Millions of shorebirds rely on tidal flats as feeding stops during epic migrations. The mud exposed at low tide is a buffet of worms, crustaceans, and mollusks. If these flats disappear under rising seas or misaligned tides, entire bird migrations could collapse. Coral spawning and the lunar calendar. Not just fish, even corals time mass spawning events with lunar and tidal cycles. Once a year, under a full moon, coral colonies release eggs and sperm into the water simultaneously, ensuring survival in a vast ocean. The tides then carry these fertilized eggs far and wide to settle on new reefs. The pulse of a living ocean. Close with a wide view. All these migrations, big and small, are connected by the moon's pull. Every shellfish, every bird, every whale plays its part in the ocean's grand, hidden clockwork. Remind your viewers that when they stand at the water's edge watching the tide come in, they're watching life itself move to a rhythm as old as Earth. Extreme tides and natural phenomena. In this act, your viewers will travel to the wildest places on Earth where tides don't just lap the shore, they thunder through narrows, spin into whirlpools, and flood entire plains. These spectacular extremes prove that even the gentle moon can create moments of raw, unstoppable power. The world's biggest tides. Start with the Bay of Fundy in eastern Canada, home to the highest tidal range on Earth. Explain how the bay's shape funnels and amplifies the tide. At its peak, water levels can rise and fall over 16 meters, over 50 feet, twice a day. That's like the ocean inhaling and exhaling an entire canyon of water. Why some places have giant tides. Unpack the science. Extreme tides happen when local geography aligns perfectly with the moon's pull. Narrow bays, funnel shapes, and the natural resonance of water sloshing back and forth can all magnify the normal tide into something colossal. Tidal bores, rivers that flow backward. Revisit the phenomenon of tidal bores, dramatic surges that roll up rivers when an incoming tide forces a wall of water upstream. Explore new examples: the Severn Bore, UK, the Chientang River, Silver Dragon, China, and the Amazon's Pororoca, each a roaring, surfable wave created by the moon's tug on vast coastal waters. The Saltstraumen Maelstrom. Travel to Norway to witness the world's strongest tidal whirlpool, the Saltstraumen. Explain how massive tidal currents squeeze through a narrow fjord, creating swirling vortices up to 10 meters wide. Fishermen have navigated these waters for centuries, and today it's a site of adventure for divers and scientists alike. The Naruto Whirlpools. Move to Japan's Naruto Strait. When the tide rushes through the narrow channel between Awaji Island and Shikoku, it spins up huge, shimmering whirlpools. Tourists gather on bridges and boats to watch the sea twist and churn, a natural show driven by the same moon we see every night. The Mont Saint-Michel phenomenon. Bring viewers to France's iconic Mont Saint-Michel. At certain spring tides, the tide races across the mudflats at up to 15 kilometers per hour, so fast, locals say it comes in as swiftly as a galloping horse. The island's ancient abbey has survived these dramatic tides for centuries. The Boar Tide of Tinigan Arm. Jump to Alaska's Tinigan Arm, where a dramatic boar tide surges into a narrow inlet, creating a single wave that surfers ride for miles. Describe how the shape of the fjord traps and pushes the ocean's energy deep inland, another example of local geography amplifying the moon's force. Tides that flood deserts. Reveal the surprising fact that in places like the Wadden Sea, Netherlands, Germany, Denmark, vast mudflats appear and vanish daily. Entire sandbanks emerge at low tide, then disappear under meters of water in hours. These shifting landscapes are among Europe's most important tidal habitats. When tides and weather collide. Highlight how extreme tides can turn deadly when combined with storms. Explain historical storm surges like the North Sea flood of 1953, when a massive tide and wind-driven surge devastated coastal Europe. Scientists now monitor tides and storms together to protect millions. The awe of tidal extremes. End this act by reflecting on what these spectacular tides teach us. The moon's pull is subtle yet mighty, shaping our planet's most extreme natural shows. Whether it's a whirlpool spinning in a fjord or a boar wave racing up a river, each phenomenon reminds us how small we are next to nature's hidden forces. The hidden mathematics of tides. If the moon's pull is the heartbeat of the sea, mathematics is the language that lets us predict it. Your viewers will learn how sailors, astronomers, and mathematicians joined forces across centuries to tame the ocean's rhythms on paper, and now, with supercomputers. The first observers. Begin with the ancients. Greek, Roman, Chinese, and Arab sailors watched the tides rise and fall for trade, fishing, and war. They kept rough records, noticing connections between the moon's phases and the ocean's moods, even if they couldn't yet explain why. Medieval tide tables. Fast forward to medieval Europe and Asia. Coastal monasteries kept tide charts to plan safe passages for pilgrims and merchants. These early tide tables were often local and full of errors, but they laid the groundwork for centuries of observations. Newton's breakthrough. Enter Isaac Newton. In 1687, he proposed the first scientific explanation for tides in Principia Mathematica. He showed how the moon's gravity pulls the ocean into a bulge. It was a revolution, turning tides from folklore into physics. Laplace and the tide equations. Meet Pierre-Simon Laplace, the French mathematician who took Newton's ideas and made them practical. In the 18th century, he wrote the first set of tidal equations, still the backbone of tide prediction today. He showed how the Earth's rotation, ocean depth, and coastline shape affect local tides. Lord Kelvin and the tide machine. Travel to Victorian England. Lord Kelvin built the first mechanical tide predicting machines in the 1800s. These Girancam contraptions solved complex tidal equations long before digital computers existed. They looked like steampunk masterpieces, using dozens of gears to trace out a wavy line predicting high and low tides. The harmonic method. Explain how modern tide prediction uses harmonic analysis. Each place has dozens of tiny tidal waves caused by the moon, sun, Earth's tilt, and ocean shape. By measuring these constituents over years, scientists build a precise fingerprint for every harbor and bay. Computers take over. Show the leap to computers. In the 20th century, the world's navies and port authorities switched from mechanical tide machines to electronic calculations. Early computers could churn through the equations in minutes, giving ships and coastal cities better predictions. Tides and satellites. Reveal how satellites change the game. Modern altimeters orbit Earth, bouncing radar signals off the ocean to measure tides globally. This real-time data feeds into sophisticated models that help predict not just today's tides but also how climate change will shift them. Everyday uses of tide math. Make it personal. These hidden equations shape daily life. Fishermen plan trips. Surfers watch for perfect tidal windows. Engineers build bridges and sea walls. Entire economies depend on knowing exactly when the sea will rise and fall. The living equation. End with a thoughtful reflection. Tide math isn't static. It changes with the Earth's rotation, melting glaciers, and shifting currents. The moon writes its story in the sea, but humans read it in numbers, graphs, and models. A conversation between cosmic motion and human curiosity that never really ends. The moon's influence beyond tides. For centuries, people have wondered, if the moon can move entire oceans, what else does it touch? In this act, you'll guide your audience through the hidden science and folklore of the moon's other powers, from earthquakes and rainfall to the age-old belief that a full moon stirs our wild side. Earth tides, the solid ground that moves. Open with the mind-bending fact. The moon doesn't just pull water, it tugs on solid rock. Scientists call these tiny shifts earth tides or body tides. Explain how every day, the crust flexes by up to 40 centimeters as our planet subtly breathes under lunar gravity. Most people never feel it, but precision GPS and gravitational sensors do. Tides beneath volcanoes. Zoom in on volcanoes. The moon's pull can slightly stress magma chambers. Some studies suggest that small eruptions may be more likely during certain tidal cycles when Earth tides gently squeeze or relax volcanic vents. It's not a guarantee, but it shows the moon's tug reaches deep below our feet. The moon and earthquakes. Explore the controversial question, can the moon trigger quakes? Geologists have found a slight increase in shallow tremors when tides are highest, but for big quakes, the link is weak. Still, the idea that the moon's rhythm can add just enough stress to tip a fault over the edge keeps scientists fascinated. Lunar pull on the atmosphere. Reveal that tides don't stop at land and sea, they ripple through the air too. The moon's gravity creates tiny bulges in Earth's atmosphere called atmospheric tides. Though small, they influence wind patterns, cloud formation, and sometimes even storm development. Does the moon affect weather? Unpack myths and reality. Old farmers' almanacs claimed the moon could predict rainfall and frosts. Modern science shows slight correlations, like more rainfall during full or new moons in some regions, but the effect is subtle. It's a reminder that the moon's pull touches almost every layer of our world. The full moon and human behavior. Dive into the most famous lunar legend, that people act strangely during a full moon. The term, lunacy, comes from Luna, the Roman moon goddess. Emergency rooms, police stations, and folklore all claim more chaos on full moon nights, though studies show mixed results. Sleep and the lunar cycle. Share recent sleep research. Some studies find that people sleep slightly less and have lighter sleep around the full moon. Theories range from ancient evolutionary vigilance to the simple fact that a bright full moon once lit up the night. Either way, it's another link between our bodies and that glowing disk in the sky. Wildlife and the moon. Expand beyond humans. Many animals follow the moon's cues. Predators hunt by moonlight. Corals spawn under full moons. Even plants like mangroves time seed release with the lunar cycle, ensuring seeds drift with the best tides. The moon and culture. Tie it to culture. Show how lunar calendars still guide farming, fishing, and religious festivals around the world. Many communities plan rituals, harvests, and migrations based on the moon's cycle, a living example of how our ancestors' observations still shape our lives. The moon's gentle command. End with a poetic moment. The moon's power is soft but constant, tugging at oceans, mountains, air, and dreams alike. It reminds us that we live in an intricate web of gravitational ties, always moving to rhythms far older than our cities and machines. Tides on other worlds. We think of tides as an earthly phenomenon, but the dance between gravity and motion happens across the universe. This act shows how tides sculpt planets, warm icy moons, and maybe even keep alien oceans liquid and alive. It's proof that the moon's pull has cosmic cousins. Gravity's cosmic stretch. Start with the basics. Tides are simply the stretching of a body under gravitational pull. Explain how Jupiter's massive gravity pulls at its moons, stretching them into football shapes and flexing their interiors with tidal heating. This same force makes entire moons glow with hidden warmth. Europa's hidden ocean. Zoom in on Europa, Jupiter's icy moon. Under its frozen crust, scientists believe there's a vast saltwater ocean kept liquid by tidal forces. As Europa orbits, Jupiter's pull flexes the moon's interior, generating heat that melts ice deep below. This means tides might make Europa one of the best places to look for alien life. Geysers on Enceladus. Move to Saturn's moon Enceladus. NASA's Cassini probe found giant plumes of water vapor shooting from cracks near its south pole. This is tidal heating at work. Saturn's pull stretches Enceladus, creating friction and liquid pockets that blast jets into space, proof of an underground ocean. A world of tidal fire. Reveal Jupiter's moon Io, the most volcanic body in the solar system. It has no oceans, but tides here are fierce. Jupiter and neighboring moons pull Io so hard it bulges up to 100 meters every orbit. That flexing melts rock into magma, fueling hundreds of lava-spewing volcanoes. Titan's methane tides. Introduce Titan, Saturn's largest moon. Titan has lakes and seas of liquid methane and ethane, and they experience tiny tides too. Saturn's gravity pulls on these alien seas, causing waves and currents that shape Titan's otherworldly coastlines. Exoplanets and tidal locking. Zoom way out to exoplanets. Many planets orbiting close to their stars are tidally locked, meaning one side always faces the star. This creates extreme conditions. A scorching day side, a frozen night side, and possibly strong tidal flows in any oceans that exist. Tidal heating and alien habitability. Explain how tidal heating might keep alien worlds warm enough for life, even far from a star. planets and moons orbiting giant planets could have warm subsurface oceans thanks to constant tidal flexing. This expands our idea of where life could exist in the universe. Tidal forces shaping orbits. Show how tidal forces affect the orbits and spins of moons and planets. Earth's tides are slowing our rotation by about 1.7 milliseconds per century, and pushing the Moon away by about 3.8 centimeters each year. In other systems, tides can spiral moons inward, or make planets drift closer to their stars. How we search for alien tides. Share how astronomers look for hints of tidal heating on exoplanets and exomoons. They use telescopes to find wobbles in orbits, heat signatures, and plumes of vapor, signs that tides may be shaping hidden oceans. The cosmic tidepool. Close with a poetic vision. Across the cosmos, tides act like cosmic stirring spoons, keeping water moving, crust flexing, and energy flowing. Wherever gravity pulls an object's orbit, there may be warmth, liquid, and maybe life, all thanks to the same invisible dance we see at our own shore. The future of tides, new frontiers and research. We've seen how tides shape our world, and how they ripple across the cosmos. But what about tomorrow? In this act, your viewers will explore how humanity is learning to read the tides more precisely, harness them more sustainably, and even predict their surprises decades ahead. Smart tide prediction. Begin with the revolution happening now, advanced models powered by AI. Explain how supercomputers and machine learning take real-time satellite data, historic tide records, and weather systems to forecast tides with pinpoint accuracy. These tools help coastal cities prepare for flooding, fishing fleets plan trips, and renewable energy firms pick the best days to generate power. Satellites watching the sea. Show how satellites like Topex/Poseidon and Jason-3 use radar altimeters to map the ocean's surface to within centimeters. This data reveals tiny shifts in sea level, allowing scientists to track tidal changes and even spot early signs of storm surges or El Niño events. Citizen science and tide gauges. Reveal how communities are pitching in. People around the world are installing low-cost tide gauges to monitor local changes. Citizen science networks feed this data into global databases, creating a clearer picture of sea level rise and unusual tidal patterns. Tidal Energy 2.0. Dive into how the next generation of tidal turbines is being designed. Unlike early prototypes, new turbines are quieter, safer for marine life, and more efficient in slower currents. Countries like the UK, Canada, and South Korea are already testing entire underwater tidal farms. Floating cities and rising tides. Show a bold vision. Some architects dream of building floating neighborhoods that rise and fall with the tide. These amphibious communities could adapt to sea level rise instead of fighting it. An idea gaining traction from the Netherlands to the Maldives. Climate models and tidal surprises. Explain how better tide models help predict the future of flooding and coastal erosion. As melting glaciers add fresh water to the oceans, local tidal patterns can change unexpectedly. Scientists run simulations to see where nuisance flooding will become daily life, and how communities might adapt. Protecting coastal ecosystems. Show how new research is focusing on restoring marshes, mangroves, and coral reefs. These natural barriers work with the tide to reduce flooding and erosion, and they store carbon, helping fight climate change at the same time. Indigenous knowledge meets technology. Share stories of how coastal indigenous communities are combining ancient tide knowledge with modern science. Some tribes in the Pacific Northwest and Arctic maintain traditional fish traps and clam gardens that function better when managed alongside tide charts and climate forecasts. Extreme tides and emergency planning. Point out that we'll rely more on real-time tide prediction during hurricanes and tsunamis. Emergency managers already use tide models to plan evacuations and build early warning systems for coastal disasters. The endless horizon. End on an inspiring note. The moon's pull is timeless, but our ability to live with it is always evolving. From new energy to smarter cities, humanity's future with the tide is a story of adaptation, respect, and curiosity. As long as we keep listening to the rhythm of the water, the tides will keep guiding us. Tides and human imagination. The moon's pull doesn't just move oceans, it moves us. In this act, your audience will see how people across cultures and centuries have used the rise and fall of the tide as a symbol for time, change, longing, and connection to something bigger than ourselves. Tides in ancient myth. Begin with ancient stories. The Greeks saw Oceanus as a river encircling the earth, endlessly flowing in and out. The Maori of New Zealand have legends of sea deities who push and pull the tides. Even Norse myths include the Midgard serpent, whose movements were said to stir the sea's rise and fall. The moon as a goddess. Explain how many cultures personified the moon as a feminine figure linked to water. From Selene and Artemis in Greece to Chandra in India and Chang'e in China, the moon's phases and the ocean's tides became a poetic mirror for the cycles of life, fertility, and mystery. Tides in literature. Bring your listeners to the written word. Writers from Shakespeare to Tennyson used the tide as a metaphor for human fate, a force that rises and falls, offering moments to act or be swept away. Quote lines like, "There is a tide in the affairs of men," to show how the sea's motion echoes our choices. Painters and the tidal shore. Take them into art, painters like JMW. Turner captured the drama of tidal estuaries and stormy coastlines. In Japanese ukiyo-e prints, tidal flats and moonlit bays appear in tranquil scenes. Show how the shifting tide became a favorite subject for artists who wanted to capture nature's fleeting moods. Songs and sea shanties. Drifting to music, sailors' songs and shanties often mention tides, as promises of safe passage or reminders of danger. Modern musicians too, from classical composers to folk artists, use the tide's rhythm to evoke longing, departure, and return. Poetry of the sea. Share how poets have long used the tide to express the passage of time and emotion. Emily Dickinson, Pablo Neruda, and modern poets write about the pull between land and sea as a mirror for human desire, the way love, grief, or memory comes and goes like a tide. Film and tidal symbolism. Explore film. Directors often use the tide to set mood or mark change. In movies like The Piano or Life of Pi, the sea becomes a character. Its tide's a reminder that nature is both nurturing and merciless, endlessly shifting under the moon's spell. Tides in ritual and ceremony. Highlight how coastal communities still weave the tide into rituals. Some fishing villages hold moon festivals, launching lanterns that drift out with the outgoing tide, carrying prayers. Surfers gather at dawn to honor friends lost to the sea, always respecting the tide's timing. Personal reflections by the sea. Bring it close to the listener. Almost everyone has stood on a shore, watching the tide come in or out, feeling small yet connected. The ocean's rhythm becomes a meditation, a gentle lesson that change is constant, and nothing stays still for long. The creative tide within us. End on a hopeful note. The same force that lifts the ocean lifts our imaginations. When we write, paint, dream, or sing about the tide, we're honoring our connection to the moon, the sea, and each other. All bound in a dance that's never truly still. When the tides turn dangerous. For all their calm beauty, tides can reveal their wilder side. They can combine with natural disasters, surges, and king tides to reshape entire coastlines overnight. In this act, you'll guide viewers through the hidden risks, the science behind these extreme events, and the ways people adapt when the ocean suddenly turns on them. Understanding tidal surges. Begin with the basics. What happens when normal tides meet extreme weather? Explain how strong winds and low-pressure storms push extra water toward the shore, creating a storm surge that rides on top of the normal tide, making it dramatically higher. The perfect storm, when tides and hurricanes collide. Show real examples. When a hurricane or cyclone makes landfall during a high spring tide, the combined effect can devastate coastal cities. Use historical events like Hurricane Katrina and the 1953 North Sea flood to illustrate how this deadly synergy works. King tides, nature's highest highs. Introduce king tides, the highest predictable tides that occur a few times a year when the Earth, Moon, and Sun align perfectly. They are not storms but natural events that reveal where future flooding might occur as sea levels rise. Coastal flooding in a changing climate. Expand on how climate change worsens these risks. As sea levels rise, normal tides creep higher, storm surges reach further inland, and coastal flooding becomes more frequent, even on sunny days, what scientists call nuisance flooding. Tsunamis, tides with a violent twist. Clarify the myth. Tsunamis are not tides, but they interact with tidal cycles. A tsunami that hits during high tide is much more destructive. Explain how underwater earthquakes, landslides, or volcanic eruptions create these deadly waves. Tidal bores and dangerous currents. Circle back to tidal bores. While beautiful, they can be perilous. Explain how a sudden surge rolling up a river can overturn boats, flood homes unexpectedly, and create whirlpools powerful enough to drag swimmers away. Legendary floods and tidal catastrophes. Take your viewers through history, from the St. Lucia's flood, Netherlands, 1287, that killed tens of thousands, to the 2011 Japanese tsunami's horrific coastal devastation. These events show how when tides combine with other forces, they become catastrophic. Communities that adapt to dangerous tides. Share stories of resilience. Some coastal towns have built massive flood barriers, like the Thames Barrier in London, to hold back surges. In Bangladesh, entire villages are elevated on stilts. In Venice, the Mose project deploys underwater gates to block high tides. Warning systems and preparedness. Show how modern forecasting saves lives. Tide gauges, satellites, and AI-driven models help predict surges days in advance, giving coastal communities time to evacuate or protect property. Living with the wild side. End this act with a balanced reflection. The same moon that gives us gentle tides can, with the right conditions, unleash devastating power. Nature's rhythm can never be fully tamed, only understood and respected. To live by the sea is to accept both its gifts and its fury. Tides in folklore and superstition. For thousands of years, people have stood at the edge of the sea and felt something bigger than themselves. When the tide rose or vanished without explanation, it sparked legends, some comforting, some terrifying. This act will reveal how cultures worldwide turn the moon's pull into a source of ghost stories, taboos, and timeless tales. Ancient ocean gods and goddesses. Begin with the oldest stories. The Greeks worshipped Poseidon, the earth shaker, whose mood stirred storms and tides. In Polynesia, Kanaloa ruled the ocean depths. In Hindu myths, the ocean was churned by gods and demons to create life-giving nectar, a story echoing the eternal push and pull. Moon deities and tidal magic. Show how the moon and tides were inseparable in many traditions. Some Native American tribes believed the moon was a grandmother spirit whose gentle pull guided the sea's breathing. In Japan, Shinto shrines still honor lunar kami linked to fishing luck and safe voyages. Sea spirits and restless ghosts. Introduce eerie coastal folklore. In places like Cornwall or Ireland, fishermen spoke of drowned sailors whose spirits rode the tides back to shore. Legends tell of ghost ships that appear at high tide, vanishing with the ebb. These haunting stories remind us how the sea can both give and take. The sirens and other luring spirits. Dive into tales of mermaids and sirens, mythic beings said to lure sailors onto rocks during strong tides. From Homer's Odyssey to Scandinavian Selkie legends, these shape-shifting spirits personified the sea's dangerous beauty. Tidal omens and bad luck. Explore superstitions. Some coastal communities believed launching a boat during a wrong tide would bring bad luck. Sailors often waited for a favorable tide and a good moon phase before embarking. Breaking these unwritten rules could doom an entire voyage. Tides and werewolves. Surprise your viewers with a twist. The moon's tidal link inspired old fears of lunacy and shape-shifting. In medieval Europe, people believed that the full moon's tide of light could awaken werewolves. The word, lunatic, comes from luna, a nod to these fears. Sea monsters and tidal rips reveal how dangerous tidal currents fed tales of sea monsters. Whirlpools like Norway's maelstrom were said to swallow entire ships. What was really a powerful tidal eddy became, in folklore, the lair of krakens or ancient dragons. Rituals to appease the sea. Explain how fishermen and coastal dwellers made offerings to calm the tides. In parts of Scotland and Ireland, villagers would pour whiskey into the sea or tie ribbons to driftwood, asking the ocean spirits to be gentle and the tides kind. Tides as portals and thresholds. Dive into the symbolic. Some cultures see the tide as a gateway between worlds. When the tide is low, it's a time when spirits can cross a liminal space. Coastal burial grounds and ancient standing stones often stand where land meets the shifting sea. The lasting spell. Conclude this act with reflection. Even today, standing by the surf under a full moon can feel like stepping into an old legend. The tide's rhythm reminds us we're part of stories older than memory, myths that remind us to respect, fear, and cherish the ocean's living pulse. Tides and the human body. When we look at the moon pulling the ocean, it's tempting to ask, does it pull us too? After all, our bodies are mostly water. For centuries, doctors, philosophers, and dreamers have connected the moon's cycle to our health and minds. This act will explore which of those connections hold water, and which remain beautiful mysteries. Ancient beliefs, humors, and lunar pull. Start with the earliest medical ideas. Hippocrates, the father of medicine, wrote that the moon influenced the humors, the four bodily fluids believed to control health. In medieval Europe, physicians scheduled surgeries according to lunar phases, believing that blood would flow more or less freely depending on the tide. The moon and madness. Explore the root of the word. Lunatic. Many cultures once believed that a full moon could trigger madness, seizures, or strange behavior. While science has found no solid proof that the moon drives people mad, the myth persists. Emergency rooms and police stations still report a full moon effect. Sleep and the lunar cycle. Dive into modern research. Some studies show people sleep slightly less and have lower melatonin levels around the full moon. Others find no effect. Speculate with your viewers. Could ancient humans, more sensitive to moonlight, have evolved to stay alert when nights were brightest? Fertility and menstrual cycles. This is one of the oldest claimed links. The average human menstrual cycle is about 29.5 days, the same length as a lunar month. Some studies suggest a weak correlation between lunar phases and fertility, but the evidence is mixed. Still, many cultures honor the moon as a symbol of womanhood and renewal. Birth rates and the full moon. Ask the popular question, do more babies really arrive on full moons? Hospitals have analyzed millions of birth records. Most show no consistent spike, but some midwives and parents swear they see a rush of deliveries during big lunar phases. The tidal metaphor for emotions. Show how poets and psychologists alike have used the tide as a symbol for human emotion. Freud spoke of psychic tides, and modern therapists sometimes describe emotional swings as natural ebbs and flows, a comforting reminder that nothing stays stormy forever. Animal behavior and human connection. Compare us to other animals, crabs, fish, and coral time their breeding to lunar cycles and tides. Could humans have once been more attuned? Share stories of indigenous coastal peoples who planned rituals and hunts by watching the moon's pull. Water in our veins. Ask your viewers to ponder, if our bodies are 60% water, could the moon's gravity tug on us like it does the sea? Physicists say our small size makes the effect negligible, but the idea feels right to many who feel restless or dreamy under a full moon. Modern biorhythm research. Look at biorhythms and circadian science. While the moon isn't the dominant factor, sunlight is. Some researchers are revisiting whether lunar cycles subtly shape our hormones, sleep quality, or immune responses. A personal tide. Conclude with an invitation. The next time your audience stands by the sea at night, they can wonder whether the same moon lifting the tide might be lifting something within them too. Maybe it's not about hard evidence, but about staying connected to a rhythm older than words, older than thought. The future of tidal energy. We've seen how tides shape coasts, guide ships, and even spark myths, but can they also light our homes and cities? This act explores how engineers, scientists, and coastal communities are working to transform the moon's pull into clean, predictable power. The promise of the tides. Begin with the big picture. Unlike wind or solar, tidal energy is utterly reliable. The tides rise and fall every day, like clockwork, for billions of years to come. This predictability makes tidal energy uniquely attractive for countries seeking stable renewable power. How tidal turbines work. Explain the basics. Underwater turbines are like windmills placed in strong tidal currents. As water flows past, it spins the blades, generating electricity. These devices can be anchored to the seafloor or suspended in midwater, depending on the depth and current. Tidal barrages and lagoons. Describe another method. Tidal barrages work like small dams across estuaries. When the tide comes in, it fills a basin behind the barrage. When it goes out, the water is released through turbines. The UK and South Korea have tested large-scale versions, while newer, tidal lagoon designs promise less environmental impact. Challenges beneath the waves. Be honest about the difficulties. Salt water corrodes machinery, tides can carry debris, and marine life must be protected from spinning blades. Engineers are constantly redesigning turbines to be more robust, efficient, and wildlife-friendly. The world's first projects. Take your audience to the pioneering sites. The La Rance tidal power station in France has generated power since 1966. In Scotland's Orkney Islands, the Magen project is the world's largest planned tidal stream coastal array, communities pushing the technology forward. Share stories of small communities embracing the tide. Some remote villages in Canada and Northern Europe now run partly on tidal power. Their experience could guide future coastal cities in harnessing local tidal currents for clean, decentralized grids. Environmental concerns and solutions. Tackle the big question: how do we keep marine habitats safe? Show how new designs use slow-turning blades, acoustic deterrents, and smart sensors to minimize harm to fish, whales, and other ocean life. Researchers also monitor sediment flow to protect sensitive estuaries. Combining tides with other renewables. Explain the dream of a hybrid future, using tidal power alongside offshore wind, wave energy, and solar panels. Smart grids could switch between these sources depending on weather and demand. Tides provide steady, baseline power to keep the lights on. The investment and innovation race. Look at the business side. While upfront costs are high, governments and private companies are investing billions into testing better materials, larger turbine arrays, and new coastal sites. International partnerships are sharing lessons learned to speed up progress. The moon's gift to tomorrow. End with a poetic vision. Our ancestors looked to the moon and saw mystery. We look to it now and see potential. If we listen to the rhythm of the tide, we may find a way to power our homes, protect our seas, and live in harmony with the forces that shaped life itself. The eternal dance, our future with the tides. From the moon's silent pull to crashing waves on rocky shores, the tide is more than water. It's a symbol of how we move with the world around us. This act is a final invitation for your audience to see how our past, present, and future are forever linked by this gentle, powerful force. a rhythm older than words. Begin with awe. Tides have moved across this planet for billions of years. Before the first fish swam, before the first human walked along the sand. They are nature's heartbeat, marking time in a language that needs no words. Generations by the shore. Share how countless generations have depended on the tide's reliable pattern. Families fished tidal flats, sailed on favorable currents, and told stories under moonlight reflected on the water. Our ancestors trusted the tide long before they understood its science. Science unlocks the secrets. Celebrate what we know now. We've gone from fearing the tide's mysteries to calculating them with satellites and supercomputers. We can predict the next king tide, the next surge, and the subtle dance of gravitational forces with astonishing precision. The power in the pull. Remind your viewers, the same tide that shaped our shores can power our cities. New generations of engineers are working to harness this eternal motion. Making the moon's pull one of our cleanest, most reliable energy sources. Facing rising seas. Acknowledge the challenges. Climate change means the tide's future holds more extremes. Sea levels are rising, storm surges are stronger, and communities must adapt. But the same knowledge that once feared the ocean now helps us live with it more wisely. Stories we still tell show how the tide still flows through our imagination. Myths of moon gods and sea spirits, poems and songs, they remind us that the ocean's pull shapes not just our shores but our inner worlds, our art, and our dreams. Guardians of the coast. Honor those working to protect fragile tidal zones, scientists restoring wetlands, communities planting mangroves, and indigenous peoples keeping ancestral traditions alive. Their work ensures the tide can keep nurturing life for generations to come. The tide in you. Invite your audience to feel the connection. When you stand at the water's edge, you sense the moon's distant pull in your bones. Our bodies, mostly water, echo the ocean's rise and fall, a quiet reminder that we're part of this cycle, not separate from it. What we leave for the future. Ask a powerful question: what kind of tide will our children inherit? Our choices, to protect the coast, embrace clean energy, and respect nature's rhythms, will decide whether the tide remains a source of life and wonder, or a threat to fear. The dance goes on. Close with an image: the moon, drifting through the night sky, forever pulling at the ocean's edge. Long after we're gone, the tide will keep moving, a reminder that some dances are eternal. And when we listen to its rhythm, we remember that we,